Hi, everyone, and welcome to our first lesson on Hess's Law. This is going to be a very brief introduction to Hess's Law. So let's get right into it. So Germain Henry Hess was a Swiss-born Russian chemist. He was around in the early 1800s, and he's the one who created Hess's Law. He named it after himself. So Hess's Law states the heat needed to convert one chemical into another is always the same. So if we have a reaction here, we go from A to D, it's going to have some heat, and that's our delta H. So Hess's law also says that it's independent of the number of steps taken to get to the desired product. So if we start with A and get to D, it doesn't matter how we got there. So if we take the blue path here, we can see that A turns into B plus delta H1, which turns into C plus delta H2, which turns into D plus delta H3. And from the definitions we have above here, we can see that the delta H from our red reaction, A to D, is going to be the sum of the delta H's that it took to get to D from A the long way, which is in blue here. So why is this important? So this is important because at the time, it provided insight into the development of the law of conservation of energy. It also laid the groundwork for Josiah Gibbs to develop and study thermodynamics. You might have heard of his equation, which is the Gibbs free energy. So it's also an important thing that we utilize, or important concept that we utilize, because labs can be busy and expensive. So the cost of setting up a lab and finding time to schedule yourself in to get into the lab, that can take a lot of time. So having a mathematical way to use Hess's law is very important. So it also allows chemists to calculate the heat of formation of reactions that don't take place directly. So there's some applications to Hess's law. One of the most useful ones is when we use Hess's law for reactions with unstable intermediates, which can be hard to measure in a lab setting due to time dependence. So if we think about rust, that's a chemical process, a chemical reaction that happens, and it takes a long time. Could you imagine sitting and waiting for the rust to finish building up? It takes a long time. So we can also calculate heat changes of phase transitions using Hess's law, and some other ones here that we're not going to talk about in detail, but are also good to mention. We can use it to find electron affinities based on theoretical lattice energy. We can calculate heat change when a substance changes allotropes, and find the lattice energy of ionic compounds. So you can click the link here to take you to the next video, which is technically the first video of the series. Hope you enjoy.